Okay, so on this question, they're giving us a bunch of graphs. And they're telling us if all the graphs above have equations with the form y equals ab to the x, then some questions about biggest a and b and stuff. So what are we talking about here? Well, first off, what these are these are exponential equations. Let me write one out. Y equals, and let me just make one right here. Like how about 3 times 2 to the x? That is what we call an exponential equation. Let me write that word a little better there. Exponential. Why? Why is it exponential? Because x is in the power zone. Exponent. X is an exponent. See what I'm talking about there? X is an exponent on that one. X is up in the power zone. Now, watch out. If you have x squared, you might say, well, that's exponential too. No, even though that has a power, x is not in the power zone. So that's not exponential. Let me just make it clear. So this kind of thing would not be what we call exponential. I can't write and spell. I mean, I can't talk and spell. Exponential. So that one's not. That making sense? So it's not just that it has powers, but that x itself is up in the power zone. That's what we mean by exponential. Okay. Anyway, so what? So what? It's exponential. Well, let me graph it for you real quick by making a little table. Try that again here. So I'm going to make a little x, y table, meaning if I put in x equals 0, what do you get? 3 times 2 to the 0. I'm just going to plug in a couple points, see what I get. If you plug in 0, you get that. Now, what is 2 to the 0 power? Well, it's 1. I don't know if you remember, but anything to the 0 power is 1. So that's 3 times 1. That's 3. Now let's plug in 1. So I'm just plugging in some points here. 3 times 2 to the 1, which is 3 times 2, which is 6. Plug in 2. What do you get? Let's do one more. 3 times 2 to the 2, which is 3 times 4, which is 12. Okay, now what if I was to graph that real quick? Graph that real quick here. What does that look like on an XY axis kind of thing? Well, over 0 up 3. So that's this point, 1, 2, 3 right here. Over 0 up 3. Next one is 1, 6, right? Over 1 up 1, 2, 3, 4, 5, 6. My graphs are off a little bit, but I'll just say that's 1, 6. And then over 2 up 12, 7, 8, 9, 10. It'll be about right there. There's 2, 12. So you see what that function's doing? It's going up like a real quick, isn't it? It's zipping up. Look at that. It's exploding upwards. That's what we mean by exponential growth. I don't know if you ever watch the news or read something that goes, blah, blah, blah is growing exponentially. They mean it's exploding. You see how that graph starts exploding upward? If I did one more, by the way, if I did 3, it would be 24. Sorry, at 3, it'd be like way up here on the next one, like that. It'd be like over 3 up 24. I mean, it's just exploding to the right. That's what an exponential function means. It just takes up. Why? Because that x is up in the power zone. That means things happen quickly, powerfully. Okay, so what? Well, basically, what's making that graph go up really fast? Do you notice what's happening from number to number here? See how it's doubling? 3 times 2 is 6, times 2 is 12. It's going times 2 every time. See that? See how it's doubling? Every time x goes up by 1, the y doubles. Why? Because of that 2 right there. You see, that 2 is making it double. That's the b. I want you to see what I'm trying to say is when you have, because down here they say, it's kind of in the way here, I can erase it. Y equals ab to the x. So a times b to the x. That b was what we call the base of the exponential. B stands for base. And it's what makes the thing grow. So the bigger that number is, the faster the exponential function will explode. Okay, and now what's the role of the a? The a, look on ours. What did I have in front? I had a 3, You see, that's where it starts. A equals 3. Why? Because when you plug in 0 at x equals 0, the other part cancels out, just becomes 1, and you just get your A. Do you see that? When x is 0, b to the 0 is 1. You got to remember that with exponential functions. Super important in this section. Put that in your deep, long-term memory. Anything to the 0 power is 1. What is 17,462 to the 0 power? Answer is 1. Not 0, 1. Really important that you know that. Anything to the 0 power is 1. Therefore, my point in all that is that when you, right here, if you put in x equals 0, b to the 0 will be 1. So this is just a times 1. It's just a. Meaning when you're right in the middle at x equals 0, right, as opposed to 1, 2, and 3 and stuff, you know, when you're right in the middle, x equals 0, the height of the function will be a. It'll be that number in the front, won't it? Okay, so long story now concluded. What is the conclusion of the matter? When you have a function of the form a times b to the x, the a is where it's the height in the middle. Let's put it that way. It's the height in the middle of the graph. It's the height in the middle. And the b is how fast it grows or explodes to the right. How fast it grows to the right. How fast it goes up. How about how I say that? How fast it goes up as you're going to the right. We see that. So the whole reason I made that table, you don't have to make that table, but the whole reason I made that table and did that was to show you the truth of this conclusion. So here's the conclusion of the matter. When you're looking at an exponential function of the form a times b to the x, the a, the number in the front, is the height of the graph. Got my T there, huh? The height of the graph in the middle, and the b, the base of the thing that has the x on it, we call that the base of the exponential, tells you how fast the function grows to the right. Okay, well then let's answer the questions now. Here we go. Getting back to the, oops, I'm scribbling here. Getting back to scribbling. Getting back to the question. Looking at it, they ask us, which graph has the largest value for b? What's b again? B is how fast it goes up to the right, how fast it grows, explodes to the right. So which one of these graphs, the yellow, red, blue, or green, or black, I guess, I get 1, 2, 3, 5 of them, which one goes up the fastest as you go to the right? If you're driving your car, this was a mountain, which one, a roller coaster, which one's going up the steepest? The red one, right? This red one. See, he's going up, 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 up. He's way ahead of the blue one. That makes sense? See how he's already getting steeper and steeper and steeper? So that red one right there, largest B value, because he's going up the fastest. See how he's already higher than the other ones? The blue is going up pretty quick too, but not as fast as the red. How do I know? The red started below the blue, and now he's above the blue. So he's going up faster, isn't he? The black's going down. The yellow's going up, but not as fast as the red. The red's already ahead of him. So that's the largest B, would be the red one, whichever. Well, what is that? R. Yeah, R for red. Okay, next one. Which has the smallest B? Well, that'd be the black, because the black one's going down, actually, isn't it? It's going down to the right. Tracking with me? So the black one right here, which they put with a K, the black one with the K has this, they just didn't want to use B again, I understand. That one has the smallest B, because that one's actually going down to the right rather than up. Finally, which graph has the largest value for A? Now, what's A again? A is the height in the middle. So which graph is the highest in the middle? The yellow one right here, huh? Oh, orange. I guess it's orange. The orange one right there. The orange one. The orange one is the highest in the middle, because he's at a height of 2 in the middle, The other guys are all at a height of 1 in the middle. So the orange one, the O, is that one. And so there we go. We've been able to figure that out.